Okay, good morning everyone, and welcome to this talk about the cybersecurity compliance tsunami and how we could survive it with security as code. My name is Henri Haverinen. I come from Finland, from a Finnish company called cyberismo. I'm a co-founder and cybersecurity consultant. So this talk has it's maybe a little bit unusual talk about the Cyber Resilience Act, because we also have a live demo, so that's going to be interesting. But we'll start by going over the problem. Why is compliance such a big problem? Why is it so challenging to adopt these standards and regulations? We'll be focusing on the Cyber Resilience Act in particular. But then we'll go to one of the emerging approaches, one of the solutions that you could be using to solve it. And so it's called security as code. We'll introduce the concept, we'll discuss some of the benefits, some of the drawbacks, and then we'll discuss 3 examples. I'll quickly demonstrate or just show you 2 existing solutions, the Open Policy Agent and NIST OSCAL. And then I'll be showing a live demo of cyberismo, which is a solution that we have been building, an open source solution for security as code. And there will also be something special in the very last couple of minutes, so make sure to stick around. And so there will be peaches and cream at the end, I promise. Anyway, the problem. So cybersecurity is becoming really critical, and the root cause is that the threat landscape is getting more serious. So we have a war in Europe. There are malicious actors out there attacking and exploiting any vulnerabilities that our open source projects or commercial products or services might have. And as a consequence of these threats, then the customers and the users, they have increasingly demanding requirements. Often they refer to a standard. For example, if you have an industrial company, they might ask their suppliers to apply the IEC 62443 standard. Or in general, if they are concerned about the cybersecurity management of the supplier organization, they might be interested in whether you are compliant with the ISO 27001. And finally, there's this increasing regulation. If you probably saw the keynote, and the EU Cyber Resilience Act is an example. I think there are good reasons citizens and users and companies deserve more secure products, so regulation has a good purpose here. So it's even possible that cybersecurity might become a market access blocker if we don't take care of it. Let's try a socially completely safe, interactive thing here. Please raise your hand if you recognize 3 or more of these things on this slide. And I promise that nobody will be bringing you a microphone, so it's perfectly safe to raise your hand. Okay, some people actually know more than, or at least 3 of these things. Well, do you recognize at least one of these things? Okay, everybody more or less recognizes at least one of these things. So some of these are general and some of these are industry specific, and we'll now take a deeper dive into the EU Cyber Resilience Act, because that is so topical and it's impacting everything in the Union right now, or in the coming couple of years. So the Cyber Resilience Act is an act. It means that it will be a law in the Union directly. We don't need to wait for the member states to pass any national laws. And it defines essential cybersecurity requirements on connected products that you need to meet before you can place the products on the market. And it also concerns or affects open source projects if they are put to the market in the course of a commercial activity, such as commercial support. The goal is to avoid vulnerabilities. The beginning of the act mentions software updates as one of the main ways to help there. And it also brings up this documentation as one of the key areas in the act. And there are 2 types of documentation. There is technical documentation, internal specifications, and then there are instructions and information to the users, basically product manuals or things of that nature. So that's what we roughly are talking about. And to understand the requirements of the Act closer, we can use this product lifecycle view. So we have a design and development phase, then we place the product on the market, then there will be a support period. The Act actually requires that everybody must define the support duration of the support period. We must specify it, we must document it. It is the expected time of use of the product, but at least 5 years. And there are certain factors we have to take into account. And then we must keep software and documentation available at least for 10 years since placing the product on the market. Or if the support time is longer, then we have to keep software and documentation available for the support time. So if we start from the left, there is this concept in cybersecurity called shifting left. People think that we should be doing more cybersecurity work in the earlier phases of the product lifecycle. So starting from the left, from the design and development, the Act says that there needs to be a cybersecurity risk assessment. We have to make a risk assessment, and then there needs to be the way that we design, develop, and produce the product. The product must ensure an appropriate level of cybersecurity. So there needs to be a secure design, development, and production process. And as we have heard already today, the Act doesn't give any specific requirements. It just gives this overall principle. But we know from all of the existing standards that this involves a lot. It's usually understood that it contains making sure that people have the right competencies. You should maybe take some trainings. There are things you do in the requirement phase, and you document the threat model, and then there are design reviews. There are code review. There are all types of DevSecOps tools that you apply, and also effective tests and reviews. So it's a complex process. We also have a bunch of essential security requirements. For example, the product must support software updates, which, if applicable, should be automated. There is a requirement for access control. There is a requirement for protecting the integrity of data, both at rest and in transit. The requirements fit to one page of text, roughly speaking, so you could read them from the Annex 1 of the Act. It's actually something I'd recommend you to do. Then we have these two types of documentation. Technical documentation includes the design specifications, the vulnerability management process descriptions, the test plans, the test results. Also, it includes the software bill of materials, the SBOM, if applicable. And then the user manuals, they include, for example, instructions on how to securely install the product, how to take it out of use securely, and how to make sure that you are actually looking at the right version of the manual. So how do you identify the product, and how do you identify the manual and make sure that they are about the same thing? So I would say that this is definitely more than just the SBOM and the vulnerability tracking. It's a whole complex secure development process that we're expected to have. Then, when you place the product on the market, you have to make a conformity assessment where you check that you have actually met all the requirements of the Act, and then your product can be bearing the CE marking. And at that time, it's probably also a good idea to archive all the evidence and the technical documentation. During the support period, we have the responsibility to manage vulnerabilities. Often the CRA discussions focus exclusively on this point, and it is really in the center of the Act. But it's not all. As I already mentioned, there is more. When we identify vulnerabilities, we have to address them typically by making software updates. And then there are these notification responsibilities. We should notify the authorities. We should notify the users. We should notify the suppliers of our third-party components. And the first notification needs to be done within 24 hours of becoming aware of the problem. So basically, it needs to be some sort of a continuous 7 days a week activity. So that's, in a nutshell, what the Act is requiring us to do without going into the specifics. And I've been a cybersecurity consultant for years. I've been helping teams adopt cybersecurity processes in their software development. And I can tell you that it is not an easy thing to do. It's really hard. It it can take years for an organization that has the budget to buy consultants to become mature in this regard. And usually there are these process descriptions, there are spreadsheets, there are templates, there are Jira configurations, and somebody is tracking whether teams are doing what they're expected to do in their spreadsheets or Jira tickets. And also the whole concept of compliance is a little bit hard to define exactly. It's multidisciplinary. Maybe you have to have certain trainings taken. Maybe there are, depending on the standard, you could have to make sure that the visitor practices in the lobby are secure. It's not directly related to the software development, but anyway. So it's a complex topic, and but in terms of the evidence, if you have to be able to prove that you are compliant, then you could also think about compliance as in terms of the information units. You need to have some documents, some information units, which need to have certain properties. Certain information units must exist. They must have certain relationships. For example, requirements must be associated with a test plan, which must be associated with the test execution to make sure that you are all set. So these traditional solutions that you hire consultants, you do it with spreadsheets, Jira configurations over a long period of time. They don't really work well even for those teams that have the luxury of hiring consultants like myself. But especially if you think about open source projects and smaller companies, it's not working so well. So we need to do something better. And the solution that we are discussing today, it's not there is no silver bullet. It's not the only solution that you'll be needing. It is one point of view, and it's security as code. Maybe you already figured that out from the title of the presentation. So security as code refers to this idea of representing the information related to security management in plain text format, and then you get a bunch of benefits. So when you have a plain text content format and you can then manage the security related information in software version control, you get the traceability, you get change reviews, for example, pull requests, you can see the change history, it's easy to archive, it's easy to find the version if the market authorities want you to show the CRA documents from a release 5 years ago, then you can use your Git version history or your archives easily to do that. And also, you can integrate these things to your CI/CD, the continuous integration, continuous delivery pipelines, which enables automation. And that is ultimately the goal of the security as code solution. We'd like to automate as many things as possible. Of course, there are also drawbacks of this approach. You can have, because we know that there are also security managers, product owners, maybe some other like leaders of the team who are not necessarily always so hands-on with Git and text editors. It might not be so very approachable for all the roles of the team. Also, the barrier of getting started can be, at least right now, it's a little bit high because it's an emerging approach. But let's take a look at the examples that I promised to show you. So the first example is an established project, OPA, or Open Policy Agent. It's a graduated project from the Cloud Native Computing Foundation. And this is often referred as one of the key security as code solutions. So the idea is simple. You have this policy engine, Open Policy Agent, and you can ask a question, and then it will use the policy, which is written in a domain-specific language called Rego, and some data associated with the case. It uses those as its the basis for the reasoning, and then it will give you the decision. And the benefit is that since it's such a kind of a simple concept at the core, that you can apply it in many places. Typically, it's used in microservices, Kubernetes. Also, you could use it in your CI/CD pipelines or in API gateways. So it works in the production phase, not just during the development phase of the solution. An example of the CI/CD pipeline use case could be that You could have policies regarding your infrastructure as code rules. For example, you could be checking whether all the external interfaces in your Terraform are going through some certain type of gateway or something like that, and then it would fail if it's not meeting the requirements of the policy. And the RECO policy is actually, interesting that it is a form of logic programming. It is this classic way of representing information and the rules using logical, the reasoning rules using logical expressions, and then making it's a declarative language, and that you can then derive results from those rules. So that's Open Policy Agent in brief, and I recommend you to check it out. Another thing that I recommend you to check out is this solution called OSCAL, or an ecosystem, actually Open Security Controls Assessment Language. So we have one of the problems when we have several sources of compliance requirements is that you don't want to have your developers separately check for compliance against the CRA, compliance against the IEC 62443 and so forth. So there should be just a single set of security controls that the developers should look at, and then these controls would be mapped to the different standards and regulations. And this is also a plain text content format which is designed for exactly that, for describing those control catalogs and saving the manual work. Instead of spreadsheets and these manual ways of tracking compliance, you would have this XML, JSON, or YAML-based controls that you can then automate, integrate to your pipelines. And it's also vendor agnostic, and there are tools from multiple vendors. So I also recommend you to check out this if you're interested in security as code. Finally, let's come to the Cyberismo solutions. I'm from a startup company called Cyberismo, and we have our own security as code solution. And this is the basic idea of the solution. So we have the plain text content format based on ASCII, doc, JSON mainly, and a certain directory structure. And you can manage it in software version control. And we have a command line tool and also a local browser app for working with that content format. So because it's a command line tool, you can also integrate it with the CI/CD pipeline. But it's not sufficient to just represent the data, the information, for example, your test plans or your risk assessments in some kind of plain text format, but you also need to do something with the data, and that's why we have a query and reasoning engine. We're also using a logic-based engine. It's called Klingo, from the Potasco project from the University of Potsdam originally. And it is a form of logic programming called answer set programming. I know it sounds kind of a little bit scary and formal, and especially if you look at the tutorials, it looks all mathematics. And I must admit that I don't really even understand all that mathematics. But I've found that this technology is very powerful, and once you get over this initial hurdle, it is straightforward and easy to define these rules. So it becomes like a classic expert system with some reasoning rules. This classic form of AI that has nothing to do with machine learning. So based on that engine, we can run queries. We can, for example, derive key performance indicators. We can make automated policy checks, check if we are compliant with the regulation or not. Or we can visualize our data using graphs. And now we get to this interesting demo part where we will see how this looks in practice. So here we are on the command line. I mentioned we have a command line tool. So we can type the name of the tool, and it will print us some help. One of the commands is validate. So it looked really simple. It just printed that it validated the project structure, but it did a lot of checking against different types of JSON schemas. It maps the whole directory structure to a JSON object and then validates that, but it also validates the contents of the files. And if we want to take a look at the content format in some kind of overview, then maybe you know the tree command. It will print out the contents of a directory like this. So we can see that we have all these information units or documents. They have a unique ID. We call this cards. So this card has this kind of weird it's demo underscore something. And there is an ASCII doc file, and there's a JSON file. And then there are, in the C directory, you can have child cards, and in the A directory, you can have attachments. So that's the structure of this thing, but quite quickly we will learn that this is not the way to really make it approachable, so we need a better way to see this information. And so I'm launching the Cyberismo app. So one of the commands in this command line tool is Cyberismo app, and it will then ask me to go to localhost 3000. I think I had that open here. Yes, maybe it might be a little bit small, so let me zoom in a little bit. Are you able to see? Good. Great. So the directory structure that I just showed you with the tree command, here you can see that it looks like an enterprise wiki page, really. And in this demo, we have installed some content modules. So one of the ideas is that we could make an open source project, or maybe Eclipse could make a module for you that you could install this content module, and then you have all your templates and all your things ready. We have installed some modules here, and then they include templates. We could create a decision maybe, or a task, or then that we could make a data flow diagram, data flow model, or there are different test plans here. One way to use this content is like this. So on this page, or on this card, we have a button. It says that to start secure development, I should create a workspace for my project by clicking that button. Let's try what happens. Okay, I got a whole new hierarchy of cards here. STL project -name. Maybe I'll rename this as the OCX IoT device. And yeah, there's the ASCII doc file over there, you can see. And then we have, so the ASCII doc is just, it's some content, and then we have the metadata fields visible here. And you can see that we already got a bunch of stuff, not just one page, but a whole hierarchy, and we seem to be 0% done. So that's not maybe a good news, but anyway, we are 0% done. The good news is that we have 0 security issues that require attention. So we already got some dashboard that includes these key performance indicators. I'll come back to the adoption step in a while. So we tried to organize this in this example, the content, so that you would guess that you're probably supposed to start from this foundation step. So we have 4 items here. Let's take the second one. I think this is about the competence. We should make sure that people have taken the training according to their role in the project. So maybe in this case, the HR team is supposed to do this. So we are not going to track the trainings in our project. I'm going to close this as not required. So now we can see that we are 25% done with the foundation and 7% done with the whole secure development of this thing. Maybe we can check the first task. So this says that we should make sure that people know their role, their security-related role in the project, and how to implement this control. Well, we should create a role assignment document. Well, let's do that. There's a document here that I should fill in. Maybe we'll just, to speed up the demo a little bit, I'll approve the document. I'll also approve this whole task. And now we have 50% of the foundation phase done. I was saying that it's really, it's a big deal and there's a lot of work, but if you look at this structure, then you might think that it's not that many tasks after all. In the demand phase, development phase, we have the vulnerability tracking in the operations phase. So it's not that many things actually. And the reason is that we are now targeting at the adoption step 1. So we have a way to restrict the visibility to the most important items only. If I were to change this to adoption step 2, then you can see that suddenly our progress dropped from 15% to 7%. We got a lot more things to do under the development phase and the demand phase. And I don't think we are now ready for all that complexity. Let's continue with the gradual adoption and stay with the adoption step 1. This is one of the learnings, that we should really adopt these processes gradually and in pieces. The risk assessment was one of the key things. So we need to make a threat model, and there's this one internal control here for threat modeling. So I'll review that as required, and then there's instructions again to create a document. So we get evidence, we get something to put to our technical documentation. The threat model could be for the entire OCX IoT device. And now we have a template of what kind of things we should be documenting for the threat model. This is just an example. It has been done according to the IEC 62443 standard, but so we could fill this in. There are some diagrams already here. They are actually editable raw I/O diagrams. I could edit them if I like. I could go here and launch an editor. Maybe I'll rename the app as the OCX IoT device. So we can have some attachments in the cards, and they can be even editable documents. So okay, now we got also a new attachment, some kind of temporary file from Draw.io. So we have a threat model diagram here now updated. If I show you, it's the OCX IoT device. And maybe we need to add another thread here, or because it's a threat model, we need to add a thread here. So there's another button, create a new thread. I got a new thread. This could be a serious threat. Serious security threat because it's a threat and it is critical. There are some fields that could be useful in when you manage security issues there. So anyway, that's where we are right now, and now I think it's time to make a release. We have done enough with cybersecurity right now, so let me make a release, and I'll create a new version. Let's call this release 1.0. You can see that there are these macros on these pages. It's not just standard ASCII doc, and the tool will expand those macros as a summary of some automated policy checks. So this system is now saying that we are not ready for release because there are policy check failures. That's a bummer. We have failed policy checks, and it even insults with this notion that there are no successful policy checks. And we can see that one of the checks, the first check, is that there should be no unprocessed security issues, and it's this very serious security threat that that it points to, that we just filed. And we should review this and choose an appropriate workflow transition. Also, there are some release tasks. If we open the menu, you can see that actually this screen is cutting a little bit. Maybe I should try to. It's not really scrolling down because of the zoom level, but. Now, when I created the release, we got internal release note, external release notes, release review, EU conformity assessment procedure, and now the automated check is saying that we need to do all these release tasks, like the EU conformity assessment. If I follow the link to the security thread, and maybe I can close this as not applicable, it was not really affecting our product after all. Then I go back to the release report. Now I have a successful policy check. So here you can see that if you look at these checks close, then you might notice that well, maybe nobody notices, but you could map these columns to the JUnit format. So these checks could be reported in the JUnit format in the CI/CD pipeline. You would have the test suite as SDL, the test case as internal control progress must be 100%, the error message as this, and this could be maybe mapped to the class. So we could even have the CI/CD pipeline fail if our threat model has expired and needs to be looked at again. We have still a few minutes left, and I'll make sure to leave the last minute or two to this other topic. But I wanted to show you the visualization. So if you know the C4 model, by the way, who knows the C4 model? It's a way to describe architecture. Well, some of you know it. So we took an example from the C4 model and modeled that architecture here using these cards. And then we can generate a diagram automatically from this data in the system. The data flows are just links. And so our visualization logic program just looks at the data and the links and automatically generates this. On the top level, it generates this kind of view. If you zoom down a little bit, it generates a more detailed view on what the application includes automatically from the data that we entered here. This is very useful in threat modeling. You often need to draw this kind of data flow diagrams with trust boundaries and data storages and data flows. And we made another report here just as an example that just from those links between the cards, it makes a query to the data using this logic program structure and finds out a list of external interfaces from the backend. So this is just an example from the system. And I think that I could show you a little bit more demos. I have an SBOM demo, but we only have 5 minutes left, and I would like to give you guys a chance to ask questions. So if you want me to show the SBOM demo or make a change to this visualization thing and actually see how that the diagrams update, then I can do that. If you have some questions, then we could also, or some comments, we could also have some discussions here. So any questions, any comments? I cannot hear you yet. Do I need to use the headphones? Nobody can hear you? It's probably not the right type of microphone.
Does it work? Yeah, now it works.
Now
Okay,
it
now
works.
it works.
And I can hear without this.
Okay.
Thank you, Rosaria.
So thanks again. I was wondering how much of that, you mentioned that you have created this as open source?
Yes, that we have created the tool as an open source tool, and it's a brand new thing for us. We've just made it this is the first conference where we are publicly talking about this, and we will be making these content modules also openly available later. Right now there is just this base module that you can basically use it as some kind of static documentation site, but next we will publish this, once we are completely ready, we are making this, or it doesn't have to be even completely ready, but next we will be publishing the data flow diagram module. And then we will also be working on open source modules for secure development. So this is just demo content right now that I was showing here, but we will be also making open modules for.
Yeah, but the functionality that you have been using during your demo, is that already part of your open source repository?
The tool is part of the open source repository, but the content is just demo content for this demo.
Yeah, okay. And so do I find that on GitHub?
Yes, and you can just search for CyberISMO, and you will find an introduction to the project at our website, and then links to the documentation and GitHub, and we'll be adding more there soon.
Okay, thank you.
Any other questions?
Yes, thank you. You mentioned that there is like an SBOM tool. We've got like many existing tools that create SBOMs and also license and dependencies, for example, the Eclipse Dash tool or ORT and so on and so forth. So does it work with those tools? Is it a pretty new tool? How does it look like?
Right. Okay, so this is a demo to maybe more a demo to illustrate the functionalities of this product, or this tool, rather than like a serious alternative to anything else. But in some cases, when you want to use a third-party technology, we have this internal control that you should make a risk assessment. So in some cases, you might have to track some of these big dependencies. Like for example, if we use this Klingo tool from the Potasco project, it's like independent binary that we are depending on. Then maybe we need to make some kind of due diligence or risk assessment that it actually works for us. And just for these big dependencies, sometimes you have to track them manually or create the SBOM manually. So in this demo, I've just added here a couple of fields that typically are needed in the SBOM. So I don't actually know what maybe they would have some kind of pure package URL something. And maybe there's the name would be Klingo, and let's just guess something here as the information that I might have to manually enter somewhere. So now I have all the information that typically you would need for an SBOM and also the risk assessment in the same document. And I made a query and a report in the data so that the system automatically generates an SBOM out of that risk assessment document. It's just the information that I just entered there. So to answer your question, this is not really a serious attempt yet, but more like a demo of the capabilities of the query and reasoning and reporting features of this tool. So now I think it's time to go for the special thing that I promised at the end. And this is actually a good opportunity for you to make a contribution. That's why I thought that this is a good thing at the end. So you have an opportunity to contribute and answer this survey to help Eclipse Foundation know which skills matter in open source. There's a project called Skill Lab going on, and Rosaria and Konstantinos will be able to tell you more about that. So grab your phone, and maybe during the next break you could fill in this form. So thanks a lot. I think we are now 7 seconds out of or behind our schedule. So thanks a lot. I'll be around here if you want to see more demos or discuss this in more detail.